everyone. So, in this video, we'll be discussing about protein and amino acid metabolism. End of this session, you will be able to know the definition of proteins, the structure and functions of proteins, classification of amino acids, what is amino acid pool, and then the nitrogen balance, the positive and negative nitrogen balance. Introduction of proteins. These proteins are fundamental, structural, and functional components of human body. Proteins are high molecular weight biomolecules which are made of amino acid linked by peptide bonds. These proteins are regarded as bodybuilding foods. However, 10 to 15% of total body energy is derived from proteins. Proteins can be broken down or hydrolyzed to their constituent amino acids by variety of methods, and the earliest studies of proteins naturally focused on the free amino acids derived from them. Basic functions of proteins. So the basic functions of proteins include, like, it is the fundamental basis of a cell structure and its function. The function of the cell and the cell structure contains proteins. All the enzymes, hormones, immunoglobulin transport carriers are all proteins. These protein helps in the maintenance of osmotic pressure, clotting of blood, and muscle contraction, and many more functions. And during the starvation, these proteins are the major suppliers of energy. Structure of amino acids. These amino acids are made up of an amino group. It is alkaline, and a carboxylic acid group or carboxylic group which is acidic in nature, and they are termed as amino acid if both the functional groups are attached to the same carbon atom. 300 amino acids present in the nature, in which only 20 amino acids are found in the structure of proteins. So in this slide, I'll be explaining you, or like briefing you, about the chemical classification of amino acids. So classification of amino acid based on its structure is like amino acid with aliphatic group. Examples are glycine, alanine, valine, leucine. Amino acid with OH group or hydroxyl group in the R side chain. Example, serine, threonine. Amino acid with sulfur in the side chain, cysteine and methionine. Acidic group in the side chain, aspartic acid, aspargine, glutamic acid. Alkaline group in the side chain, lysine and arginine. And aromatic side chain, phenylalanine and threosine. So this is the basic chemical classification of amino acids. Classification of amino acids include essential amino acids or indispensable amino acids. These are amino acids which cannot be synthesized by the body and therefore need to be supplied through the diet. They are required for the proper growth and maintenance of an individual. Examples for these essential amino acids are valine, leucine, isoleucine, threonine, methionine, phenylalanine, tryptophan, and histidine. The non-essential amino acids are those amino acids which are synthesized in the body from the carbon skeletons of lipids or carbohydrate metabolism, or by transformation of essential amino acids. So these non-essential amino acids, the examples include arginine, alanine, asparagine, aspartic acid, cysteine, glutamic acid, glutamine, glycine, serine, and threonine. Sorry, tyrosine. Acid pool refers to like what happens to the amino acid which enters into the body. So once any amino acid enters into the body, it should either be utilized or being excreted out. So what happens to this amino acid when it enters into the body? How is it is excreted or in what way it is being utilized is what we call it as an amino acid pool, or we summarize it as an amino acid pool. So here the source or formation of amino acid takes place through protein breakdown. That means formation of amino acid takes place through protein breakdown, or the protein intake which is being done through diet, synthesis of various non-essential amino acids from the essential amino acids. That means the amino acid is also synthesized in the body through various ways. So the amino acid which enters into the body is being utilized either for the protein synthesis. We know that proteins are the building blocks of amino acids, carbohydrate and fatty acid metabolism, synthesis of non-protein compounds, and it also is a source of energy. Those amino acids which are not utilized or which are being broken down or protein breakdown take place is being excreted out. Excess protein is excreted out from the body in the form of urea in urine. So over here, the total amino acid entry into the body should be equal to the amount of amino acid which is being utilized in the body and which is being excreted out of the body. So this whole thing we term it or summarize it as amino acid pool. Nitrogen balance truly represents the protein utilization, that is 16% of which is nitrogen. So the 16% of proteins is nitrogen. So that nitrogen utilization in the body and its loss in the body is what we call it as nitrogen balance. The nitrogen balance is determined by comparing the intake of nitrogen and excretion of nitrogen. So the intake takes place through proteins and excretion takes place through undigested protein in feces and urea or ammonia in urine. So the normal healthy adult is in a nitrogen equilibrium, since the daily intake is equal to the loss through urine, feces and sweat. So this is the general formula for nitrogen. Back to the amino acid pool. Over here, amino acids contribute to the formation of body proteins through anabolism and through catabolism. These body proteins are broken down to amino acids back. So through dietary proteins, the nitrogen is coming into the body. So this is input of the nitrogen into the body in the form of amino acids or proteins, and which is excreted through feces. Unutilized proteins or undigested proteins are being excreted through feces. The amino acid output is through excretion of amino acid through urea or ammonia. So the only way through which amino acids or proteins which are being excreted out through metabolic cycles over here is through urea and ammonia. So over here at equilibrium, the nitrogen output and nitrogen input will be same. The positive nitrogen balance is a state in which the nitrogen intake is higher than the nitrogen output. The sum amount of nitrogen is retained in the body, causing a net increase in the body protein. So this positive nitrogen balance is observed in growing children, pregnant women, or during recovery after serious illness. The negative nitrogen balance is a state in which the nitrogen output is higher than the input of nitrogen. The result is that some amount of nitrogen is lost from the body, depleting the body proteins. This, when prolonged, or negative nitrogen balance when prolonged, leads to death. This is sometimes observed in children suffering from kwashiorkor or marasmus. I hope you have understood what is proteins or what are proteins, what are amino acids, the classification of amino acids, that is chemical classification as well as the nutritional classification, what is amino acid pool, what is nitrogen balance, the positive nitrogen balance, and what is negative nitrogen balance. Hope this video is helpful for you. Thank you very much. Namaste.